Hello, everyone. Let's go to practice test for Chapter 7 review, MATC. But like I said, for all that wish to look at this, I'm going to try to make this, have tried to make all of these very, very worthwhile for anyone seeking a higher level, of knowledge of the mathematics, of the basic mathematics, that can get us into more advanced topics. Though for a basic mathematics course, some of the trigonometric considerations aren't always very highly emphasized, sometimes not at all. I figured at least I could owe this to the students taking a very, very basic mathematics class, and for students who have done a similar kind of course and maybe are a little more advanced in the whole process of doing this, to help them like in a physics class or in an engineering class. And that's for anybody actually that's taking a course like this. You may want to go into chemistry. You may want to go especially into engineering and physics, which uses a lot of trigonometry. There are 10 questions on this, so let's take a look at it. It's been a little, it's been its own challenge sometimes trying to put some of this stuff together. So let's take a look at it and see what we can do here. There's a few things we want to kind of look at, I want to kind of put down here, and we'll see what we can say. And at least get the main part here, guys, is the setup. I mean, you need to kind of, you need to know what the setup is. You need to know what the basic mathematics is. Doing something on, doing something with a calculator, that's all well and good, but you can only use the calculator and the computer when you know what it is that you're trying to solve and know how it is that you're going to solve it. So don't worry as much about, right now at least, what the final answers are going to be. If we got the setup put together, if we have the setup put together correctly, the rest becomes an issue of working with a calculator, and that's not too bad. There's a lot to talk about, and I've mentioned this in other videos as well that are available to you. Let me keep going a little bit. If you've got, let's say, a right triangle, or any triangle for that matter, but let's say this is angle capital A, this is a 90-degree angle, this is angle capital B. Well, for any triangle whatsoever, actually, this is a right triangle, 90-degree angle in it, but for any triangle whatsoever, the sum of all the degrees, the sum of all three degrees in any triangle, the sum of all three degrees in any triangle, whether it's a right triangle, acute triangle, obtuse triangle, any triangle in the universe of triangles, the sum of all the angles of any triangle is 180 degrees. So A and B, A, B, and 90 degrees, whatever, let's say this guy's C, it happens to be a right angle. If you take the measure of A, the measure of B, and the measure of C, it's going to be 180 degrees. If this is a 90-degree angle, then these two angles are complementary angles. They both have to add up to 90 degrees because 90 and 90 is 180 degrees. So if this right here is 60 degrees, this will be 90 minus 60 degrees will be 30 degrees. 60 degrees and 30 degrees is 90 degrees. 40 degrees and 50 degrees is 90 degrees. 70 degrees and 20 degrees is 90 degrees. If one of them's theta, the other one is 90 minus theta. They are complementary angles. They add up to 90 degrees. The longest side of a right triangle is called the hypotenuse. They frequently just call it C. The length of that is length C, from here to here. This is A, this is B, and in my other two films pertaining to ratios, similar triangles, the Pythagorean theorem, I prove various things, or at least give a gut feeling proof for various things, and we discuss the Pythagorean theorem among other things. And that's in other films that are available to students, both at MATC and elsewhere. I try to make the films available in numerous places. The hypotenuse squared is equal to a squared plus b squared. The hypotenuse squared is equal, The length of the hypotenuse squared is equal to the sum of the squares of the legs. In addition to that, looking at something like this, and we can say a lot. I mean, if I was, let's talk about B. If I wanted, there's different things out there, I guess you could say. There's the sine, let's say the sine of B, the cosine of B, and the tangent of B. The sine of B is the ratio of this leg divided by the length of the hypotenuse. The side opposite the angle divided by the hypotenuse. Opposite over hypotenuse. The cosine is the adjacent length divided by the length of the hypotenuse. And the tangent is basically the rise over the run. It's this rise over that run. It is the opposite over the adjacent. That's A over B. They got other things they call, they got this thing called the cosecant. The cosecant. The cosecant of B is 1 over the sine of B, which is the reciprocal of the sine of B, and in this case it would be C over A. The secant of B is 1 over the cosine of B, and that is C over B. And the cotangent of B is the reciprocal of the tangent. So the reciprocal of the sine is called the cosecant. The reciprocal of the cosine is called the secant. Let me go over here so I have a little more room for you guys. The reciprocal of the sine is the cosecant. The reciprocal of the cosine is the secant. And the reciprocal of the tangent is the cotangent. And that would be B over A. One more time here. The reciprocal of the sine is the cosecant of B. The reciprocal of the sine of B is the cosecant of B. The reciprocal of the cosine of B is the secant of B. The reciprocal of the tangent of B is the cotangent of B. And we've got what we're looking at here. So this is some of the stuff they're talking about. There's some interesting, I guess, situations that you can say. Is there another way to kind of, just looking at this ratio of A over C is associated with the sine of B. But if I was talking about it in relation to A, the adjacent over the hypotenuse would be A over C, but that would be the cosine of A. So the cosine of A would give you this. The cosine of B is adjacent over hypotenuse, but that'd be the same as the opposite over the hypotenuse for the sine of A. So, I mean, the labels depend on your reference point. The tangent of B is the rise over the run, but where, that's true. In this case, how are you going to do it? Well, the tangent of B is a little more difficult, how that's going to play out. You'd have to get, at that point, you'd have to get the cotangent of A. Cotangent of A would be, you'd get B, the tangent of A would be B over A. B over A would be the tangent of A, and the reciprocal of the tangent of A wouldn't be B over A, it'd be A over B, and that'd be the cotangent. So the cotangent of A. Well, I'm not entirely comfortable with a lot of this, but at least they're going in that direction, so I at least want to talk about this a little bit in that regard. Let's see what we can say here when we're doing some of this stuff, and let's see how it all plays out. Okay, we got what we got, guys. Let's try to nail a couple of these problems, and perhaps it's pretty reasonable. Again, I do go pretty heavily into the Pythagorean theorem and into similar triangles quite a bit. To the Pythagorean theorem and similar triangles quite a bit, you guys. when I talk about other there was another film I did, 2 other films that I did actually, and I hope it went pretty good for people when we had done so. So let's see what we got. Number 1, find the value of x, they're saying here. So let's see what we got here. They're drawing something, and sometimes this stuff cannot be easily drawn. There's a 36-degree angle here. There is a 53-degree angle here. And we're not exactly sure what the angle here is for x. Well, we do know that they all add up to 180. X plus 53 plus 36 adds up to 180. X is x. 53 and 36 is 89. You got this. Subtract 89 on each side, right? And you end up getting 91 degrees. It's almost a right angle. It almost looks like a right angle, doesn't it? Well, that's what we got. So we got that one. For 2, for the following right triangle, find the length of side x. Round to the nearest hundredth. Well, let's set this thing up and let's kind of go with the answer key on that. The big thing is let's make sure we're doing this right. Make sure we got a good argument here as to what's going on. This is length 7. This is length 9. This is length x. It's the hypotenuse. We know that c squared equals a squared plus b squared. The c is the x. You can call this guy a. You can call this guy b. It doesn't really matter who you call a or b. But so you got this guy. You got this guy. A is 7. And b is 9. And let's see what we got here, guys. Let's kind of... X squared equals, that's 49, that's 81. Add them together, I guess, right? And when you do so, you get 130. Get the square root of both sides. And there's a number of ways you can kind of work this, and how this all plays out. Don't want to quite go there on that, but let's see what they're given. I do know that there's got a lot of gut feelings here, guys. I do know that the square root of 100 is 10. The square root of 144 is 12. Okay, between 10 and 12, I guess. Yeah, it's between 10 and 12, I guess. The square root of 121 is 11, so we can get a little better than that. The square root of 121, if this was 120, square root of 100 was 10, square root of 121 is 11, square root of 144 is 12, so the square root of 121 is 11, the square root of 144 is 12. Between 11 and 12 is my gut feeling. So if something crazy happens, I can kind of check myself and find out what's going on. They got, well, we said it was between 11 and 12. They got 11.40 when they do all the round-offs when they actually do it. But again, you've got the calculator, go for it, see what you can do. Okay, let's keep going with that. Question number 3. A right triangle has sides D, E, and F as shown below. Use these links to find tan x, sine x, and cosine x. Okay, so we've got 3. They drew something here. This is not a good drawing already, guys. Let me see what I can do. This guy is measurement x. This is F. That's a 90-degree angle. This is E. This is D. And we know how to do this. Tan x, sine x, cosine x. Tan x, sine x, cosine x. The tan x is adjacent, that's E over F. Sine x is over hypotenuse, that's E over D. and E over D. And then cosine of x is adjacent to the hypotenuse. That's F over D. And there it is. So that's 3. Find sine theta where theta is the angle shown. Okay, well that's not too bad. Give an exact value, not a decimal approximation. For number 4, find the sine of theta when they give you this. Okay, well they're giving us, this is theta, frequently used for angles. This is 5, this is 12, and you know what? Sine of theta is opposite over hypotenuse. Well, that's gonna be tough. I gotta find what this is. I gotta find what this guy is right here. I gotta find what he is. To do it, it's gonna be opposite, which is 12, over the hypotenuse, which is C. Yeah, that's all well and good, but now I gotta find it. All right, so give yourself a little bit of room here, guys. Okay, so we got that. Let me go over a little bit, maybe stay relatively close, I guess you could say. You gotta find what that C is, guys. So for number 4, let's see if we can pull that off. Well, we know that C squared equals A squared plus B squared. Like I said, I did 2 films that are available to many people, both at MATC and elsewhere. If they're of any benefit, any use, please use them. So let's see what we got here. We got C squared equals A squared plus B squared. I got to find, C squared is A squared plus B squared. I don't know what C is, so I don't know what C squared is. I'm going to call this guy A, I'm going to call this one B. It doesn't matter which one you call which. They're the legs. You can call them anything you want. Let's just see what happens. C squared, 5 squared is 25. 12 squared is 144. C squared is 25 and 144 is 169. Square root each side. The square root of 169 is 13. Wait a minute, that's going to get us here, I think. So let's go kind of in the middle here. Done, I guess. Sine of theta is 12 divided by C. Sine of theta is equal to 12 divided by 13. That is it. There it is. See how they gave that answer for 4. I'm assuming, there's a number of ways you can write it. If you do write it as a fraction, we just did write it as a fraction, but if you write it as a decimal, it is a decimal that goes on, it repeats. So you have to get the repeating notation. Sine of theta is 12 over 13. It's all good. Okay, let's go to number 5. For number 5, find cosecant theta, sine theta, and cotangent theta, where theta is the angle shown in the figure. Give exact values, not decimal approximations. Okay, well, sounds good to me. So what we can do is, let me get another. All right, so we got this. We just did 4. Let's see what we can say for 5. There's theta, here's 8, here's 15. Call that guy B, call that guy A, and let's find out what C is. What C is equal to, and we'll kind of just play the games we got to play. It is true that C squared equals A squared plus B squared. As I said, I've got films elsewhere for various different audiences, whoever wants to see it, films elsewhere pertaining to similar triangles, ratios, and the Pythagorean theorem, and some pretty fascinating stuff that's been discussed by other people. I mean, long before I ever tried to discuss any of this stuff. So it's not something that's uniquely affiliated with me. This was done by brilliant people long before me, and they're trying to look at some of the stuff that they have to say. Those are other films. I mean, you can find that in various places where I have those for students. Right now, let's deal with this. We don't know what C is, so we don't know we don't know what C is. We don't know what C squared is. A is equal to 8. B is equal to 15. Let's see what happens here. C squared equals, that's 64, plus 225 when that all happens. C squared equals, you add the 2, you get 289. Square root both sides. Just make sure that's right. I'm kind of doing a little bit of this in my head, I guess you could say. Be 225. Let me just see here for 1 second, guys. Kind of do this out loud if you don't mind. 30 and 30 at 60, 225. That's 285, and 4 is 289. That's it. That's correct. So what are we going to do here? Well, they want the cosecant of theta. The cosecant of theta is 1 over the sine of theta. And we'll figure that all out. The sine of theta, maybe find the sine of theta first, might be a little easier for us. And the cotangent is 1 over the tangent. All right, there's a number of ways we can go here. Let's get it. Let's go over the sine of theta first. It might be an easy way to go. We said at the end of the day here, we said this, not decimal, give exact values, not decimal approximations. That's 17. The sine of theta is opposite over hypotenuse. 15 over 17. The cosecant of theta is the reciprocal of the sine of theta, and that's 17 over 15. The cotangent is the reciprocal of the tangent. The tangent of theta is opposite over adjacent. Opposite, let me think. Opposite over adjacent, 15 over 8 is the tangent of theta. The cotangent is the reciprocal of 15 over 8, which is 8 over 15. And there it is. That's it. That's the end of it. Okay, so the end of the day is, okay, there it is. Cosecant of theta is 17 over 15. Sine of theta is 15 over 17. Cotangent is 8 over 15. So cosecant 17 over 15. Sine 15 over 17. And cotangent 8 over 15 associated with theta. Cosecant theta, sine theta. Cosecant theta, sine theta, cotangent theta. So let's see where that is. Let's see where that kind of plays out. And right down the line there. 17 over 15, 15 over 17, and 8 over 15. So we're looking good. That's 8. That's forgive me. That's problem. That problem or question number 5 rather. question number 6. For some reason here, so they're saying they're complementary angles. Okay, let's just kind of, there's a good amount going on here. So the way some of this is asked is not very simple to look at. So we got to kind of figure out what we're saying here regarding some of this stuff, how this all plays out. I don't know how some of this got written out. Okay, let's just see here, guys. All right, for this right here, the way the question is asked is a little rough. There's a part 1, part 2, part 3, part 4, so it's kind of all over the place here. See, they don't really... Okay, they make something that's a little hard to look at here because they don't. There's not a lot talked about here. I'm going to try to fill in the blanks before I fill in the blanks of the answers. I got to fill in the blanks of the question. The question itself is not very clear. We're going to have to say, I'm going to kind of go out on a limb here a little bit. This is the hypotenuse. This is, let me see, sine of A. So I'm going to say this is A, small a, and this is big A. This is big B, and this is small b. And that's the way it's going to have to be, you guys. Opposite the big A is small a. Opposite the big B is small b. It's a right triangle. These guys are complementary angles. That means A plus B adds up to 90 degrees. That means that A is equal to 90 minus B. Or, put another way, if you solve for B, B is 90 minus A. Whatever one of them is, the other one is 90 minus the other one. If this guy's 30, 90 minus 30 gives you 60. If this guy's 75, 90 minus 75, that guy's got to be 15. They got to add up to 90. So this works. I don't know how I want to, so that's what they mean by complementary. They also told us to kind of keep in mind that the sine of A is opposite over hypotenuse. The sine of A is opposite over hypotenuse. We got that. The cosine, so let's actually write that down. Opposite over hypotenuse. And let me give myself a little bit more room, guys, if you don't mind. Sine of A is opposite over hypotenuse. Cosine of A, big A, is adjacent over hypotenuse, so that's fine. Everything seems to be consistent. The sine of B, and we've already talked about this earlier to some degree. The sine of B is opposite of B, opposite big B, that's that, over hypotenuse, that's B over C, which is the same as that. So I guess and we already talked about that can happen if you're going for if you talk about different angles. And the cosine of B, you want to bet it's going to be that? Cosine of B is adjacent over hypotenuse. That's A over C. Sure is. Look at the similarities there. So you see some stuff that's kind of interesting. And it happens. I mean, if you play the game with the angles, that is the same as that. Yeah, but it's different angles. Sine of A is this. Cosine of B is the same thing. Cosine of A cosine of A is this. Sine of B is that. Same thing there. So it's kind of neat to kind of bring that out. So look at how the circle. The stuff in blue is the same stuff. Cosine A equals sine B. Cosine B equals sine A. So, okay. Select all of the true statements here. Make sure to use the appropriate uppercase or lowercase l, fill in the blanks. I have no idea what they're asking here, guys, to be honest with you. So this is true. So I'll build it in such a way that there it is. That's correct. Part 2, use A, B, and C to fill in the blanks. Make sure that, again, I cannot follow this. All right, so select all the true statements here. They're asking one of them, is sine A equal to sine B? No, that's not true. That's not necessarily true. Sine A, sine B, no, these are potentially different things. Sine A is not equal to sine B. Is sine A equal to cosine B? Yes, we just said that. Is cosine A equal to cosine B? No. But is cosine A sine B? Yeah. So yeah, these two are equal and these two are equal. And that's basically, none of the above is true. That's not true. Two of them are true. It is true that cosine A equals sine B, cosine A equals sine B, and cosine B equals sine A. And that's those two things can be filled out there when you look at it. Fill in the blank. No idea what they're talking about on this one either, guys, to be honest with you. Cosine, if they're complementary angles. Now this is pretty interesting. This is where it gets subtle. If 90 minus B is going to be equal to A, this works. If 90 minus B is going to be equal to A, then cosine of 90 minus B is going to be the same as the sine of B. If 90 minus A is going to be B, then 90 minus A, the cosine, is equal to the sine of A. Yes, so if it's complementary angles, this is a true story. This is a true statement. You got this, because 52 degrees and 38 degrees, 52 degrees and 38 degrees is 90. Yeah, that's true. That's on the line of cosine of A being equal to the sine of B. That's in line with cosine of B. Cosine of A equals cosine of A equals sine of cosine of A equals sine of B. Cosine of B equals sine of A. Yeah, that's true. As long as the B is 90 minus A. As long as the A is 90 minus B. Or you can flip it around and talk about it another way. As long as they're complementary, that's going to be true. That's a true statement. That's a true statement. For the life of me, I do not know how they're asking this. Like I said, you can't. This stuff does not always print out really well, but it prints out well enough. I mean, we know enough. We can get this. Let's just see here. Yes. Okay. Like I said, maybe this is easier had we done it. They drew it a little different. They got it drawn a little differently than I got it drawn, guys. But what we're going to say here, A and B are complementary angles. These are complementary angles. For part 1, A and B, or A and B, are complementary. Are complementary angles. Figure out how you're going to do the actual cosines here, and I already did that. I already said, Now, I didn't draw it the way they drew it. Their rendition of the drawing, guys, is different than mine, but it's not, it doesn't really matter. If that guy's going to be B and that's going to be A, and you're going to put big C here and big A here and big B here, you know, this is B, this is A, and this is C, and it's a 90-degree angle. I'm not crazy about how they drew it, but everything is going to be fine. I mean, if you look at this, this is, here's A, here's C, here's B, and then you want to do the ratios vis-a-vis, here's A, here's B. The C right here, again, their drawing is somewhat different than mine. It's looking like that. Now, if you're going to do the sine of A, that's A over C. The cosine of A is B over C. The sine of B is B over C. The cosine of B is A over C. It's the same kind of argument. No matter how I draw it, guys, you can go off this or go off that. That's not a problem. This is what it looks like. The way they're asking this question is a little rough to look at. This is actually the answer, the complementary answer for part 3. Well, okay, sorry guys, a little bit of a mess to look at it, but let's just make it really clear. You can draw the triangle under consideration the exact same way they drew it, and the cosine of A is B over C, the sine of A is A over C, the cosine of B is A over C also, and the sine of B is B over C. And that's the same exact analogy here. It works exactly the same way. Fill this in and see the similarity. These are complementary angles. This is this. This was blank. The only way you can get a sine and cosine to be equal is if the angles are complementary. They add up to 90 degrees. What would you add to 52 degrees to get 90 degrees? You'd add 38 degrees. So that's kind of the way it looks. So it's kind of all over the place on this, guys. But this is parts 1, 2. They're not really an A, B, C. I thought there was, there's 4 parts here. So this right here is part 4 when you find this guy. When you find the 38 degrees plus 52 degrees. 38 degrees and 52 degrees is 90 degrees. If they're complementary to each other, there it is. That's part 4. Complementary is part 2, and this is more, forgive me, it's really hard to say this. This is the complementary angles under consideration. So this is part 4 right here. Man, I just don't want to put any more, there's so much stuff up here, guys, but if these guys are complementary, they add up together, A and B add up to 90 degrees, that's part 1. So, I mean, we can just do this. That's part 1. Part 2 is all this. Part 3 is just the fact that I circled these two. These are the same. These two are the same, and these two are equal to each other, whatever it is, and these two are equal to each other, and that's part 3. And then this right here is part 4, where the 38 degrees and 52 degrees add up to 90 degrees. Okay, it's a little awkward how it's put together. My fault more than anybody's fault, though, however. This is actually the drawing as it was originally, you guys. And these are the way you do the ratios at this. You gotta say, okay, this is side C. This is side hypotenuse, length C. This is side B, side length small b, side length small a, and then this is the hypotenuse. Angle A, angle B, 90 degrees. If you do all the ratios, all of this is exactly the same if you use this right here. I built my own because I wasn't sure what they were talking about initially, and this is the same. This works just the same. If you take this thing, if you take this, if you take this triangle pick it up, flip it, and make it, I guess, if you pick it up, how would you do it, actually? You'd have to do a lot. Actually, no, it's pretty easy, actually. It's a lot easier than I'm making it. You would just, if you rotate this thing counterclockwise 90 degrees, it's the same thing as that over there. These are identical. This is also big C right here, but nobody really went there. Big C, angle big C is 90 degrees. It's opposite small c. This is angle big A. This is angle big B rather. What I chose to do is just put them right in there. So it shouldn't be too bad. So we're looking at that, you guys. Let me... Seven, solve for x in the triangle, round your answer to the nearest tenth. Okay, now here we go. There's a number of ways this can be done. So when they give you this is 69 degrees. This is x. This is 13. And there's a lot going on here. Nobody asked you the question, but if that's 90 degrees and that's 69 degrees, the angle here to make them all add up to 180 is a complementary angle to 69 degrees. This would be 21 degrees right up here. 21 degrees and 69 degrees is 90, and 90 is 180. Kind of interesting that way. Tell you what I'm going to do. Is it true that the cosine of 69 degrees, whatever it may be, is equal to the adjacent over the hypotenuse? If these two things are equal, what do you say you multiply by 13 on each side? So you got this, you got x over 13. You multiply by 13 on each side. X equals 13 times the cosine of 69 degrees. The cosine of 69 degrees is, get an answer and multiply it by 13. Now, the cosine of 69 degrees is 0.3583 something times 13. 4.6587 833. Well, I'll stop right there. Round your answer to the nearest tenth. Well, that 6 barely gets rounded up, but it does get rounded up. $4.7. Let's just make sure. 4.7 it is. All right, let's go. So that was that. This was number 7. Forgive me for not emphasizing that. That's number 7, and it works all the way to here. Find x. Round your answer to the nearest tenth of a degree. Okay. There's a lot to be said here. So let's say it. You've got a length of 5 here and a hypotenuse. We don't know what this angular measurement is, but we do know that the sine of x is opposite over hypotenuse. Opposite the 90-degree angle is the hypotenuse, and opposite this is what's opposite this. Opposite over hypotenuse is 5 over 6. The sine of x is opposite over hypotenuse. Sine of x is 5 over 6. what you do is you get the inverse sign. That's not 1 over the sine of x. The inverse sign, sometimes they call it the arc sine. The inverse sine of x, you try to get the inverse sine of this ratio, 5 over 6. The inverse sine of x is x. The inverse sine of this, sometimes, and this does not mean, I know to the -1 means 1 over something. Not here. In this notation, this means arc sine. Arc sine. What is the length of the arc? What is the size of the arc in angles? So sine inverse or arc sine will get you there. The arc sine of that is 5 over 6, and they said round it to the nearest tenth of, round the answer to the nearest tenth of a degree. Inverse, so that's inverse sine, 5 divided by 6. That's 56.4427. 56.4427. To the nearest tenth, does that 4 stay a 4 or go up to a 5? I think it stays a 4. X is 56.4 degrees. That's number 8. And like I said, I didn't write 7 down too well right in the beginning, but remember how 7 played out. You just did all this. X over 13 is the cosine of 69 degrees. X over 13 is the cosine of 69 degrees. Multiply by 13 on each side. When you multiply by 13 on each side, you get x all by itself. You'll eventually get x all by itself. And x equals just that. And that was number 7. Number 8, a little more complicated. You go the arc sine, the inverse sine to get that. If you already know the ratio that pertains to the sine, you go arc sine or sine inverse of that ratio. It'll tell you what degree measure it came from. Okay, so pretty interesting there. That was number 8. Number 9. A 17-foot ladder leans against the side of a house. The top of the ladder is 14 feet off the ground. Find x, the angle of elevation of the ladder. Round your answer to the nearest tenth of a degree. Okay, same argument that we just did. Same argument that we just did for number 8. So I'm going to probably leave number 8 up there when I do 9 over here. Let's leave 8 up there, guys, just to kind of a reference. It's going to look a lot like number 9 is going to look a lot like 8. So let's see what we got here. Make the long and the short of it make some sense for us, guys. For number 9, they're saying, looking something like that. We don't know what this angle x is. We want to know what it is. The ladder's 17 feet long, and it's leaning up against the building. And it's got an altitude of 14. The building does, where it's leaning, so right there. First thing comes to my mind is the sine of x. The sine of x is opposite over hypotenuse. It's got all the attributes of a right triangle. They basically tell us it's a right triangle. Certainly works. Do the inverse sine or arc sine of x on each side. And if you got a little confusion on that, don't worry too much about it. The inverse sine of the sine of x is just x. just jump here if you want. Get the inverse sine of the ratio pertaining to the sine. From what angle does this sine measure come from? The inverse sine will tell you if there is this ratio of a sine value, if this is the sine value, if this is the ratio pertaining to a sine value, what angle got you there? What angle got you there? If this is the ratio of the sine value, the inverse sine tells you for this ratio of a sine value, from what angle did it come? So you hit the inverse sine of 14 over that, round your answer again to the nearest tenth of a degree, so you can say inverse sine 14 over 7 forgive me, 14 over 17 rather, 55.4397, forgive me, 55.4397 about. Round tenth of a degree. Does that stay a 4 or go up to a 5? Sure looks like it's staying. 0.4 degrees. So yeah, I mean that's what we're getting here. Let me just let's just confirm this. I'm sure we're fine. Just always good to kind of watch out a little bit. I got 55.4 degrees. That's what they got. Okay. So that sounds good to us. That's that. Number 10. Let's see where it plays. For number 10, solve the right triangle. Round your answers to the nearest tenth. There's a lot here, but I think we can do it. So what we're going to do is, again, we've done a good amount. Let me put this thing right side up, I guess you could say. I'm not sure what right side up is, though, but let's have a look here. This is 15. This is B. This is the hypotenuse. That's a degree angle. This is a 57-degree angle, which means if they're complementary, for the record, this is a 33-degree angle. Nobody asked, but 33 degrees and 57 degrees is 90, plus 90 is 180. Okay, looking pretty good to me. This, as we said, is 15. All right, sorry guys. If it's not broke, don't fix it. I think it was fine the way it was, but the reason I was worried you guys might not see this too good. All right, this is 10, and this is 15. Okay. And I guess they're asking for a number of things here. Solve the triangle. I guess that'd be nice to know what the hell's going on. I think they're asking for A too. Well, A we just got. A is this guy. It's complementary. A equals a 33-degree angle. We're looking good. So we got that one. What else is going on? Let's deal with the 57, I guess. I don't know. It's your call. We can say that the sine of 57 degrees is opposite. Well, hold on. Oh, we gotta find what C is too. So that's gonna be a little rough. Okay, I'll tell you what we're gonna do. Let's be careful. Let's get the cosine of 57 degrees. Cosine of 57 degrees. Cosine of 57 degrees is adjacent over hypotenuse. So adjacent is, let me see here. Adjacent, the cosine of 57 degrees is adjacent divided by hypotenuse. Sounds good to me. Let me tinker with this. Let me multiply by c on each side. C times cosine 57 degrees. And let me divide by cosine 57 degrees on each side. I'm going to divide by cosine 57 degrees on each side. I got this. Yeah, that's equal to 15 divided by let's have a look here. I will go, let's go cosine 57 degrees first. Point 0.54464. 0.5446. That divided by that. I'm going to kind of do something on the calculator here, kind of make it equivalent to that. I got 27. 27.5412. Roughly. So that's that. Round off when we need to do the round off. The round off's not going to be too bad. I could probably just tinker with this one when it's time. Now let's just get this under control. So we got this. That's C. B. You can play this a whole bunch of ways, I guess. What do you say we take the opposite over the adjacent? Let's try to get, that's not the only way we can go now. We can do a lot of games here. Now that we got C, we can do stuff with cosines and sines. We can do things with 57 degrees. We can do things with 33 degrees because we solved that earlier. There's a lot that we can do. Tell you what, let's take this guy, the B, and let's take this guy, the 15. This is a rise, so to speak, if depending upon your perspective. Opposite over adjacent. Opposite is B over adjacent is the tangent of 57 degrees. Opposite this guy is B. Adjacent is this. Okay? So opposite over adjacent is the tangent. Multiply by 15 on each side. Let's find what the tangent of this guy is. I mean, might as well. Tangent of 57, 1.5398, 1.5399. Well, I got that for the tangent times the 15. $23.097, 23.098. All right. Well, yeah, good enough for me. Let's do the round-offs, I guess, and hopefully it's going to be confirming with everything here. We're saying round to the nearest tenth. Here's the 5. Does it go up any higher? Well, what's next to it is a 4, so it doesn't. So what we have here is Stays as is. This guy right here. Here's the 0. Right next to it's a 9. That's going to round up to a 1. I mean, we've got B is 23.1, C, let's put C up here. C equals 27.5, B equals 23.1, A equals 33 degrees. I'm pretty confident they're gonna confirm it with us. Yeah, that's what we got. We've got the angular measurement of A. I guess they had this one as A. Yeah, the angular measurement of capital A is 33 degrees. The measurement of small b is 23.1. The measurement of small c is 27.5. All right, guys, there it is. We got one more film after this, and we're looking pretty good. It's going to be just practice test for Chapter 8. Thank you for your time. Look for it, and good luck to you guys.